Hi guys, in this video tutorial I am going to talk about electrolysis, which is an important section in electrochemistry. So first thing that you need to know is the difference between an electrochemical cell and electrolytic cell. In electrochemical cells, you know that the reactions are spontaneous, so we use spontaneous reactions to generate electricity. So in an electrochemical cell, we use anode and cathode as two species, and you connect to the electrodes, then you generate certain electricity. But in an electrolytic cell, you need to understand the reactions are not spontaneous, so you need to make these reactions happen by force. So in that case, you need to supply external energy. So we use batteries and risers to supply external energy, or we use an electrochemical cell separately to provide energy to an electrolytic cell. So in an electrolytic cell, the terminals are different, because in an electrochemical cell, the species, the electrode which we use as anode, have a negative charge, and the species which use as a cathode, that means the electrode cathode, have a positive charge. But in this case, the scenario is different, because in electrolytic cell, you need to understand always the electrode which is connected to the negative terminal acts as the cathode, and the electrode which is connected to the positive terminal always act as anode. So that is what I have given in the picture. Anode contains positive terminal and cathode contains the negative terminal. Anyway, the processes are not different. Anode always it is oxidation, cathode it is reduction. That is what you need to understand. So the process that we perform using electrolytic cell is electrolysis. And in your syllabus, in the new syllabus, we need to basically discuss 4 different types of electrolysis. First one is the electrolysis of water using platinum electrodes, then electrolysis of copper sulfate using copper and platinum electrodes, and last one is electrolysis of NaCl aqueous and NaCl liquid. So we will see how we perform. First, we will talk about electrolysis of water. So electrolysis of water, which results in liberation of H2 and O2, which are the components of water. So we supply external voltage, and here we use inert electrode, that is platinum, so which will be acting as the surface for the anodic and cathodic reaction, and catalyze the formation of H2 and O2. You need to understand very important thing about the electrolysis of water. So you know that the ionization of water is very much poor, so it will give very little amount of H plus and OH minus. So passing a current or electricity through the solution by ion is very much poor. So in that case, it is very difficult to perform electrolysis of water. So to make that easier, so we need to add a small amount of sodium sulfate or sulfuric acid, so the ions in the solution will be high now, and it gives a significant amount of electricity passing through the solution, which will easily use the anode and cathode reaction favoring. So anode and oxidation happens, so positive charge. And what is the oxidation? So water, you have H plus and OH minus. So oxidation can be performed by OH minus giving O2, and reduction can be happen at the cathode. So H plus will take 2 electrons, that means 2H plus 2 electron will generate H2 gas. But I recommend you to write this using water molecule, because writing H plus giving reduction of H plus to H2, or either OH minus oxidized to O2 is not a complete reaction actually. That is just to understand the concept. But when you are writing this anode and cathode reactions for water, that is more complete. So always try to write down this reaction as this. So how to identify? So anode means oxidation. So when OH minus is oxidized to O2, so the remaining species should be H plus. So that is what you have added as 4H plus. In reduction, cathode, so when H plus is reduced, so what is the remaining one? That is OH minus. So that is what OH minus is added to OH minus. So when you balance these two reactions, you can multiply the cathodic reaction by 2, and when you add, the overall reaction will be 2H2O liquid giving 2H2O gas and 2H2 gas and O2 gas. Right, the next thing is electrolysis of copper sulfate. So in this case, you need to know and you need to understand you can perform electrolysis of copper sulfate using copper electrodes as well as platinum electrodes. So there is a small difference where when you are using copper electrodes, copper is a reactive metal. So just under hydrogen in the activity series, copper is a reactive metal. So when you connect copper electrodes to the solution of a copper sulfate, the anodic reaction will be copper giving copper 2 plus aqueous plus 2 electrons. Now the solution does contain few ions. This copper sulfate aqueous means the solution contains copper 2 plus, sulfate SO4 2 minus, H plus and OH minus. So what are the species that can perform the anodic reaction? That means oxidation. So the which is OH minus can give O2 by oxidation, and what else? Copper 2 plus, H plus, no, those will go towards the cathode for reduction, and the other thing is SO4 2 minus. So by considering these species, you need to consider the reactivity of the metal as well. So although you have OH minus and SO4 2 minus to perform the anodic reaction, here there is a reactive metal, so it will go towards the anodic reaction. That means the oxidation will happen at the anode. So copper will be oxidized to copper 2 plus giving 2 electrons. That is the anodic reaction. So for the cathodic reaction, again you have what? You have H plus, you have copper 2 plus. So which is more favored for reduction? So as you know, copper 2 plus is below H plus, that means H2 in the activity series. So copper 2 plus will reduce and deposited in the cathode. So color of copper sulfate aqueous solution. So what do you think about the color? So you can understand copper is giving copper 2 plus, and same amount of copper 2 plus will be reduced to copper solid. So there will be no change in the color of the copper sulfate solution. So the nice blue color will not change. But when you are performing this same electrolysis with platinum electrons, now you need to understand these electrodes are inert. So in that case, there should be some species undergoing oxidation from the solution. So from the solution you have OH minus and SO4 2 minus. So from those two, OH minus favors the anodic reaction. So you know that OH minus should be oxidized to O2. So I told you in the previous case you need to write the complete reaction. So 2H2O liquid giving O2 and releasing OH plus and 4 electrons. So write these reactions because this is very important. And in cathode again you have copper 2 plus, so this reaction is same as when you are using copper electrodes. So what will happen to the color of the solution? So you know here only copper 2 plus is taken from the solution to deposited as copper solid. So in this case the color of the solution fades, then been reduces after you perform the electrolysis for a certain period of time. Right. The next thing is electrolysis of NaCl aqueous and electrolysis of NaCl liquid. So NaCl liquid, that is the molten NaCl fused chlorides we use to perform electrolysis to extract sodium. So in the electrolysis of NaCl liquid, we use graphite anode and steel cathode. So you can use the same electrodes for electrolysis of NaCl aqueous, but I have taken here platinum. So I have given a few important data. So reduction potentials of sodium plus Cl minus, then H plus as well as OH minus. So when you are talking about the electrolysis of NaCl aqueous, so you have 4 different ions again. So Na plus, Cl minus, OH minus and H plus. So the anodic reaction, for the anodic oxidation, you need to understand when the reduction potential is more negative, it favors the anodic reaction, oxidation. So according to that, when you take the two species which can reduce, that is Cl minus and oxidize Cl minus and OH minus, you can see the reduction potential of water is a little more towards the negative side. That means 1.23 is less than 1.36. so for oxidation, the oxidation of OH minus to O2 should be favored. But here actually the anodic reaction is 2Cl minus aqueous giving Cl2 gas. The reason for this is, although the oxidation of OH minus is favored thermodynamically, there is another factor which determines its oxidation, that is the kinetic factor. So according to the kinetic factor, OH minus is not favored, Cl minus is more favored. So when you are talking about anodic or cathodic reaction, other than the thermodynamic factor, you need to talk about the kinetic factor as well. So in this case, the anodic reaction is 2Cl minus giving Cl2 gas and 2 electrons. The cathodic reaction, automatically according to the electrode equilibriums, you can see that H2O, that means H plus, should be reduced to H2 gas. So I have given the overall reaction of NaCl aqueous. But when you come to NaCl liquid, so you don't have either H plus or OH minus, so automatically Cl minus will be reduced to Cl2, oxidized to Cl2 actually, so Na plus will be reduced to Na solid. So according to that, try to write the overall reaction here. You need to balance the reaction and add the two reactions. So up to now we have learned the electrolysis of water, then copper sulfate solution using platinum electrode as well as copper electrodes, then electrolysis of NaCl using graphite as anode and steel cathode as, then another NaCl aqueous solution by using platinum electrodes. Now in the second part of this section is about the Faraday's laws on electrolysis. So I have given an observation, you can read it. So first thing about electrolysis, Faraday's law, what you need to know is what is 1 mole of charge. That means 1 mole of electrical charge. So you know the charge of an electron multiplied by the Avogadro number, so you will get roughly 96,488 coulomb per mole. So you can write that as 96,500 coulomb per mole. So 1 mole of an electron contains this amount of charge. So I have given a nice example to calculate how much copper is deposited in the reduction, that means in the cathode. So if the charge passed through the solution is Q, so you can find the electrical charge moles by dividing by 96,500 coulomb per mole. So this one normally we take that as the Faraday's constant. So when you divide that by the Faraday's constant, you will get the number of moles of electrical charge. That means you will get the number of moles of electrons used. Then according to the stoichiometry, you know that 2 electrons are used to deposit copper solid. So the stoichiometry is 2:1. So from that you can calculate the moles of copper discharged or deposited at cathode. So that will be Q over 96,500 divided by 2. Then you can multiply that by the molecular weight of copper to find how much grams deposited in cathode. But in some cases, in most of the questions, they will not give this Q charge directly. So in that case, use Q is equals to IT. I means the current in amperes and time in seconds. So this is how you normally do answers for a question. So you write down this and you try to get the knowledge from this. And we will move on to the Faraday's law. The Faraday's first law, I have underlined the important terms. So the Faraday's first law, it indicates that mass is proportional to electricity passed through the electrolyte. So M is proportional to Q, which means M is proportional to IT, and M is equal to EIT. So E means electrochemical equivalence. So my previous example is the use of this Faraday's first law to perform calculation to find how much mass that is deposited in the cathode for copper, or either how much mass that is given out that may as oxidation in the anode. You can use any reaction because you are using same current for either reduction or oxidation. So in this case, what you need to basically know is that mass is proportional to the amount of electricity passed through the solution. That is what Faraday's first law gives. In the second law, Faraday stated that when you have different cells and still if you are passing same amount of current into different cells, the masses will be proportional to equivalent weights. What do you mean by equivalent weights? So equivalent weight means the chemical equivalence, capital E. So that will be normally mass over valency or mass over charge. So you can understand this clearly by looking at the next picture. So we will take two cells, cell 1 and cell 2. So in cell 1 the reduction is given, in cell 2 the oxidation is given. So this electrolysis is performed for 10 minutes by supplying a current of 9.65 amperes. So by using Q is equal to IT, you can find the charge that is given. Then you can find the moles by using Faraday's constant. So I have calculated the moles as well, that is 0.06 moles. So this is equal to the electron moles either in cell 1 or cell 2, because in cell 1 as well as in cell 2 the electrolysis is performed for 10 minutes by giving a same amount of current. So in cell 1 the stoichiometry between the electrons and copper is 2:1, but in cell 2 it is 1:1. So in cell 1 the copper deposited moles will be 0.06 divided by 2, but in cell 2 it is same as 0.06. So based on the stoichiometry you can find the number of moles, and even you can find the mass as well, multiplying this by the molecular weight of either copper or sodium. So what you need to understand here is you can have a nice question regarding this. So please go through the last paper 2019. So it is basically on this explanation. So if you know this explanation clearly, you will be easy to answer the question in 2019 electrochemistry in essay part. Next we are going to talk about an application on electrolysis. So one of the important applications of electrolysis is electroplating and electrorefining. So electroplating means we are using electrical current to reduce cations in the solution in cathode. That means we try to coat a material on cathode. So the cathode should be something that to be plated. So the part to be plated is normally used as the cathode. So here the electrical supply should be minimum and steady. So the reason for this is when your electricity is very much small and steady, the coating will be uniform. That is the important thing. But if you supply a big current, the coating will be not uniform, and the material should be very well uniform as well, otherwise it will form some cracks. The process used here is electrodeposition, and the part to be plated should be the cathode of the circuit. So basically we use two techniques. So in technique 1, the anode is made up of the material to be plated. So what is happening here in anode, oxidation of the material happens, and ions will be in the solution, and these ions will get again reduced and deposited on the cathode. That means the part to be plated. So that is one technique. In the other technique, for anode we use non-consumable platinum For cathode, again the part to be plated. So what is happening in this case is you need to periodically arrange these species in the solution so that our material is reduced at cathode and deposited in the cathode. So that is what we perform here. The only difference between the technique 1 and technique 2 is technique 1, the material to be plated, we use that as anode. In technique 2, we use platinum, that means an inert electrode as the anode. So the common example of electroplating is gold. So as you might have seen in many cases, gold is coated in imitation rings. So what is happened here is here we have used technique 1, in which gold get oxidizes to Au plus, then again gold get reduces to Au and deposited in the ring. So for the electrolyte, again we use a solution which is having the ions of the material to be plated. That is another important thing, right? Then electrorefining. So electrorefining, again it is oxidation reduction performing electrolysis, but here electrorefining means that is the purification of a given metal. Now as you can see in the example, the anode that contains 99% of copper contains some important metals like silver and gold. So when you perform the electrolysis, the anodic reaction will be copper giving copper 2 plus ions. So when this oxidation happens, the important metals like silver and gold will be deposited at the bottom, and again as the cathode reaction, copper 2 plus will be reduced to copper solid and deposited in the steel blank. So you can have pure copper as well. So you can separate the gold and silver separately and you will have the pure copper here. So that is the electrorefining process. So the other important thing about electrolysis is you need to understand here when you are performing electrorefining, it is better you use again a small steady current, because that is important to perform this electrolysis. So up to now I have discussed about electrolysis and the important concept, that means applications of electrolysis, that is electroplating and electrorefining. So now we will talk about corrosion and controlling corrosion. So this corrosion part is added to the new syllabus as you need to know that the surface of iron, when you have this oxidation reduction, that forms rust, act as a electrochemical cell. That is the important thing that you need to understand. So corrosion is normally considered as the oxidation of metals into their ions, and rust, that means oxide layer, is a result of corrosion. So when you have iron, the iron oxidized to Fe2 plus, so that is what means by corrosion. So corrosion can take place for any metal. So what you need to understand, according to the picture, see there is two separate reagents, anodic reagent and cathodic reagent. So in anodic reagent, iron gets oxidized to Fe2 plus. In cathodic reagent, oxygen takes these electrons from the anodic reagent and performs its reduction. Meanwhile, in the water molecule, Fe2 plus with dissolves oxygen oxidized to Fe3 plus, then it comes with connects with water and form rust as well. So this is the result of corrosion. So this this area acts as an electrochemical cell, because the electrons that is given out from the anodic reaction is taken by the cathodic reaction. That is what you need to understand. This performs like an electrochemical cell. The other important thing about this corrosion is the factors which affect this corrosion. So when you increase the temperature, the electron flow will be high in this metal, and the other important thing is mobility will be high. So important part is mobility. So when mobility is high, that means mobility of ions is very high, this corrosion will take place at a higher rate. And the other thing is concentration of oxygen or diffusion of oxygen. When more oxygen is there, more cathodic reaction will be there. That means more electrons are removed from the anodic reaction, so Fe will be more oxidized to Fe2 plus, which is the anodic reaction, and this equilibrium will be favored towards the forward reaction. And the next thing is pH. So think about the pH in the cathodic reaction. Again, you can see H plus is used. So if you have a low pH, that means acidic medium, that means acidic condition, cathodic reaction is performed very well. So again, it will induce the anodic reaction and it will increase the corrosion as well. Then finally, that is about conductivity. So conductivity means the moving ability. So if these ions moves, so this corrosion will happen very fast. This is directly in relation with temperature as well, because when you increase temperature, the conductivity will be high. So how you can control this corrosion? So basically we perform two methods. One is cathodic protection and the other one is anodic protection or passive ion formation. So in cathodic protection, you need to understand we use iron as the cathode. That means we use another metal which is as the anode, which is more reactive than iron. So the corrosion will happen to that metal as given in the picture for zinc, giving zinc 2 plus and 2 electrons. And these 2 electrons will be taken by iron to perform its reduction reaction. Okay, so cathodic protection means you use iron as the cathode and you use anode as another different metal which is more reactive than iron. So iron will not be corroded, but the metal will be corroded. But you need to understand a very important thing about this cathodic protection. Normally zinc giving zinc 2 plus ions and 2 electrons, it will happen at a normal rate. But when you connect this to an iron bar, normally we say this is galvanizing. So when you galvanize with zinc iron, when you galvanize with zinc, the corrosion of zinc will happen at a greater rate than its normal condition, because as you can see in the diagrams, the electron given by zinc 2 plus is taken by oxygen in cathodic region in iron. So this will induce another greater rate for the corrosion at zinc. So this is also referred to as bimetallic corrosion as well. So understand the fact, when you are galvanizing iron with zinc, even though iron is protected, the corrosion of zinc is happening at a higher rate because electrons are removing from zinc and goes towards iron. So when you are coating with zinc, please make sure you are coating with a big area. So that is one important thing. In anodic protection, you make the iron as anode and you cover with a less reactive element as the cathode. That means you are covering all the iron with a less reactive metal. But you need to understand, if there is any space that oxygen can diffuse and oxidize iron to Fe2 plus, then the corrosion will happen. So you need to make sure there is no cracks, no air spaces and etc. etc. Right, so what you need to know about this lesson is, first we talked about electrolysis, then applications of electrolysis, that is electroplating and electrorefining. Then I talked specifically about the corrosion, which is another important thing that you need to understand. So why I have included corrosion here is talking about corrosion in electrochemical cell is not related, because electrochemical cell you need to understand that separately. So I have included here corrosion as an application of electrochemical cell. What you need to know there is, you need to know that that when rusting happens, there is a electrochemical cell that is formed. Moving on, we are going to talk about the final section. So this talks about the electrochemical system. So this part is newly added to the syllabus. So first thing what you need to know here is the difference between strong, weak and non-electrolytes. So strong electrolytes mean it completely dissociates and gives ions. For an example, in NaCl, So this is a neutral salt which will give Na plus NCl minus, completely dissociated. But weak electrolytes, if you have an acetic acid which will be in equilibrium, reversible equilibrium, which will partially dissociate to give ions. So if you have 1 mole of the electrolyte, there will be no 1 mole of the ions given, complete dissociation is not happening. So the conductivity will be little lower than the electrolytes which are very strong. Non-electrolyte, think about a glucose solution, so they do not dissociate, so the conductivity will be poor. And the next thing that you need to understand here is electrical and ionic conductors. So electrical conductivity means the conductivity or the current electricity is passed by electrons, basically free electrons. So that can be easily seen in metals as well as in semiconductors as well. But ionic conductors means, think about a solution that you have used for your electrolysis. So you know that electrolysis can be performed using electrolyte solutions. So here you don't see the current is passed through the solution by electrons. You need to understand the current is passed through the solution by ions. So here we are talking specifically about the current that pass through solutions. So recall your physics. So you know that resistance is equal to rho L over A. So L over A is the cell constant, rho is the resistivity, and R is resistance. So resistance and resistivity, which acts as a barrier for transmitting current through a metal rod. So when you get the reciprocal of it, you will have 1 over R equal 1 over rho times A over L. Now this is the opposite of resistance. That means it is called conductance. So R is resistance, 1 over R is conductance. That is per ohm, which is specifically given as Siemens. So conductivity, we use the term that is kappa. It is Siemens per meter. So what do you need to know? Get the basic idea. What is resistance and resistivity? What is conductance and conductivity? Then we need to understand what is molar conductivity. So molar conductivity is given by the symbol that is given as in the picture. So that is equals to conductivity kappa over concentration. So this concentration is molar concentration. And when you divide that conductivity by the molar concentration, you will have the units Siemens per mole square meter. So I have given some important molar conductivities of ions. So think about these molar conductivities. You don't need to by heart these values, but think about the last two, the ferric and ferrous cyanide complexes. The molar conductivity is very high. So why is it? So think about these complex anions. So these are complex anions. So think about it, can give a lot of ions. Therefore, it will have a nice good molar conductivity as well. So that is the normal reason. The last part of the lesson is the factors affecting conductivity. So I have given 3 reasons: nature of the solute, temperature, and concentration. So when you are taking or when you are talking about the nature of the solute, conductivity depends upon the easiness which the ions can pass through the solution. So if you have large ions with viscous liquids, the conductivity will be poor due to having a poor mobility. And higher in number of ions, that means when you are using an electrolyte which is completely dissolving, that means completely dissociating, so the conductivity will be high. So that is about the nature of the solute. So if you are using an non-electrolyte, the conductivity will be poor. So you need to understand there is an effect on the nature of the solute. And the second thing is temperature. So you know that in a metal, in a nice conductor, when you increase temperature, the current electricity is reducing. In a semiconductor, you know that when you increase the temperature, the current electricity is increasing little bit. So the same thing happens in solutions as well. When you increase the temperature, the mobility of the ions will increase. So furthermore, you need to understand when the mobility is increased, the conductivity is increased. That is one thing. The other thing is, you know that ionization of water, for aqueous solution, ionization of water, that is, you know the reaction is endothermic, that is a cooling process. So when you increase the temperature, that means you are favoring the cooling process. According to the Le Chatelier's principle, the ionization is favored. So there will be more ions given to the solution and the viscosity will be reduced. So therefore the mobility becomes greater by the ionization of water as well. So in that case, when you increase temperature, conductivity will be increasing. The final thing is concentration. So when concentration increases, the conductivity is reduced. So you might have misunderstood these concepts. You might think that when the concentration is high, there will be higher number of ions, and so that the conductivity should be increased. So but you need to understand this is not always correct. The important thing is when you have ions and when you are performing electrolysis or basically electrolysis, you know that anions too will go towards the anode and cations move towards the cathode. So when you have lot of ions in the solution, that means you increasing this concentration, and when you connect this to a cell, that means now the anions should go towards the anode and the cations could go towards the cathode. There will be a nice barrier for these ions to be mobile. So that is the reason why the conductivity reduces when you increase the concentration. So that's ends our lesson today, and I have given a question. So this is about the conductivity. So cell constant is given, that is L/A, and the conductivity for a given solution, that is 0.001 m. Potassium nitrate is given. So find the conductivity of a solution and calculate the molar conductivity. So try to do this question, and if you have any questions, you can comment and ask. Thank you.